I'm excited that today we are going to have an interesting technical session. Today we host Ufuk. He is the production engineering manager at Shopify. He'll be our facilitator for today. And I'm going to now stop sharing my screen so that I can transition over to him. And as I read his bio, and then he can take over. Hopefully, Ufuk, you can teach us a thing or two about pronouncing your second name. It's long. I think this is very synonymous with the Nigerians, brother and sisters. They have long names, but they have very sweet and short versions to it. So help us know that. Ufuk is the production engineering manager of the Ruby infrastructure team at Shopify, and he brings over 20 years of industry experience to the company for the adoption of better Ruby tooling and practices. Ufuk currently works remotely from Cyprus, where he lives with his beloved wife and wonderful daughter. So Ufuk, we are happy and glad to have you here. Thank you for setting aside the time. And as I transition over to you, all the best, and I look forward to this session.
Thank you. It's a privilege to be here. And yeah, I'll try my best to teach you about my last name as well. Okay, so let's get started. Thank you for that wonderful introduction, Mercy. And yeah, solidarity with the people in Nigeria, like you said. Okay, let's get started with, I want to get started with this picture on the screen. So some of you may know where this is from. It's a show called Entourage. It's about 4 actors in Hollywood, but like that's not the topic of today. There's something wrong with this picture. And I want to point it out because it doesn't hit the eye immediately. So these people are in a car driving around, but they're not wearing any seatbelts, right? So the picture is missing seatbelts. And hello, my name is Ufuk Kayserilioglu. That's how I pronounce it, at least. Like Mercy said, I'm the production engineering manager of the Ruby infrastructure team at Shopify. I am from Istanbul, Turkey originally, but currently living and working from Cyprus. And the reason why I mention that is because this is an actual footage of someone driving in Istanbul and recording themselves. It's a YouTube video of itself. But there are like many drivers like this that drive like crazily like this in Istanbul, in the streets of Istanbul. Despite that, there are many people in Istanbul who still refuse to wear seatbelts. But we know seatbelts save lives, right? So they reduce the risk of deaths by 45%. They cut the risk of serious injury by 50%. But despite that, 4% of drivers in Canada, 13% of drivers in the US, and a staggering 54% of drivers in Turkey drive without the seatbelt. I looked up some numbers for the African continent. I didn't really find that many, but I think it would be similar to Turkey based on the numbers that I've seen as well. But why is this? So when you look at the reasons, you can see that most people find them uncomfortable. Over 65 people find wearing them too restricting, and they do not think they'll ever need them. And they also think that they themselves are good drivers and they're less likely to have an accident. And I think we can also make an analogy between wearing seatbelts and wearing masks today, right? It's a similar thing. We know like wearing a mask saves potentially your life and also others' lives, but still people are refusing to wear a mask because why? It's uncomfortable, or they don't like it, or they think it like infringes on their liberties or something. But we wanted some of these seatbelt things for Shopify. So at Shopify, we have a huge code base. Our code base has around more than 20,000 Ruby files. And we have about 200,000 tests that run on every push. And they take about 20 minutes to run across 200 parallel workers. So we do a lot of testing, but doing testing isn't the same thing as wearing seatbelts, right? Because we know cars are safe. We test cars, we crash test cars, we test the individual parts of cars, yet we still choose to wear seatbelts because seatbelt is an extra protection. So even though we have tests, unit tests, integration tests at Shopify, we wanted extra safety. We wanted our own seatbelts. But we also wanted a little bit more. We wanted some magical seatbelts so that they wouldn't only like protect us, but maybe they could give us some like magical extra powers too. So wouldn't that be great? So as we were looking for something like this, we came across Sorbet. So what is Sorbet? Sorbet is a fast, powerful, static, and gradual type checker for Ruby. I just want to expand on these bullet points a little bit more. So when I say fast, I mentioned that our core code base, we have a giant Ruby on Rails monolith. Our core code base is about 20,000, maybe more Ruby files. So Sorbet is so fast that it can parse, analyze, and statically type check all this code base in seconds. And it is powerful because it has a very expressive typing system. So you can express like very complex types in the Sorbet language. And it's static because the static Sorbet type checker actually type checks your code without running it. So it just analyzes the code as it is on saved on your disk. It doesn't actually load Ruby and run your code base. So it just does static analysis. There's a runtime component too, but the biggest benefit of Sorbet is being able to do the static analysis, and that's what makes it fast. So you can imagine it being like a more powerful Rubocop, just like how Rubocop doesn't actually load your code and run it. It just looks at the syntax and everything. Sorbet also kind of does the same thing. And the main point that I'll be talking about today is that it's a gradual type checker. So many people, when they hear types and Ruby, are scared because one of the reasons why people love Ruby and one of the reasons why I love Ruby is because it's dynamically typed, right? Like I don't have to say the type of anything. I can quickly put a script together and get it done without necessarily thinking about types. But in the places where I maybe want to think about types, maybe I'm doing something critical, like I'm transferring funds from one account to another, and it's a critical operation, and I just want to be extra sure it's not like a simple script to do some like file parsing, then I might want to rely on types to give me extra safety, like seatbelts, right? So in these cases, I can just use Sorbet in those parts of the code base without necessarily using types across all of my code base. So it's not like you're switching over from Ruby to Java or anything. You can opt into as much of typing as you want across your code base. And that's the powerful feature that, that Sorbet brings, that it's a gradual type checker, and you can have as much or as little of it as you want. So just to give a quick preview of what this looks like, maybe someone in the audience hasn't ever seen Sorbet in action at all. So here's a very, very simple example code that might be coming from your code base, right? So here we have a class that represents a user, and it's got a static method on it called name from hash, and it's given a user hash, and it tries to fetch the name field, and if it can't find a name, it returns no name. And then somewhere else in the code base, you probably have this user method being called, and it's given a hash with the name Ufuk, and we expect it to fetch the name Ufuk from this hash. These two parts of the code don't necessarily have to be so close together. Usually in a code base, they're like in different files. The user class is defined in user.rb, and like where it's used is probably in some other file deep down in your class hierarchy. Can you spot a problem with this code? It's not so easy to spot when you first look at it. But if you look at it carefully, when we're supplying the hash here, I'm supplying the hash with a symbol as keys. But when this method is trying to fetch the name, it's trying to fetch the name using a string, not a symbol. So this will always actually give me no name. It will never pick Ufuk from this hash. So this is actually a typing error. Because if we had the ability to declare types, then we could have said that the hash that this name from hash is expecting should have symbols as keys or strings as keys, whichever we want. And then we can enforce that for the people who are calling our method. So let's see how we can do that with Sorbet. So we'll just add a couple of extra lines, and the main thing we're adding is this sig thing on top of the method that we're defining. So by adding this sig block, we can say that the parameters that this method expects is user hash is one parameter, and the type of user hash is a T hash, and this is a special hash that Sorbet represents, so that you can supply the type of the keys and the type of the values in the hash. So this is saying that the type of user hash is a hash with symbol keys and string values. And we can also say that this method returns a string, right? So this is actually declaring the contract of your method, what the types of your parameters are, and what's the type of your return value. So this extend tsig, we also had to add because the sig that we added is just Ruby code, right? This isn't any special syntax that you put in comments or anything. This Sorbet is actually just Ruby code, but this sig method needs to be defined by someone, right? There's a sig method that we're calling here. We're passing it a block so that Sorbet can understand this. But at runtime, Ruby needs to understand where this sig is coming from. So that's why we need to extend this tsig class, which is again exported by Sorbet runtime, so that it can define the sig method and understand these types. Now, putting this all together, we get this. So our original class definition was 4 lines of code. And here, the class definition itself became about 10 lines of code. So this indeed makes our code a little bit more verbose. It feels a little, how should I say it, uncomfortable, right? Just like how you feel uncomfortable wearing a seatbelt. But in return, you get this. So if you go into the command line and if you do bundle exec SRB, so SRB is the command for Sorbet, SRB, and then say type check and .userIB, then it shows you exactly where your error is. It says, I expected a symbol, but found a string name for argument. And it's telling us that the user hash.fetch is the line where it has a problem because it was expecting a symbol, but it found a string. And it's also giving us the place where hash fetch is defined, and it's also telling us where the error was originating. So we can just go back and fix this error because we made our contract explicit. So there was one more thing in that file. What is that typed to true thing at the top of the file, right? We also added that, which I didn't talk about. So that's gradual type checking in action. And I want to talk about that a little bit. So with Sorbet, the gradual type checking, you can enable type checking at the file level. So you can opt into file checking per file or opt out of type checking per file. Or you can do type checking at a method level. So you can only add signatures to the methods that you want and leave the others without signatures. You can opt into type checking at an argument level or at a call site level. right? So these are like all the different levels that you can opt into file checking. So let's start with file level granularity. So Sorbet has this concept of strictness levels. And these are the strictness levels that it allows. So the lowest strictness level is typed ignore. And if you put typed ignore at the top of your file, then all errors about that file are silenced. Actually, Sorbet doesn't even analyze files that are marked as typed ignore. It completely ignores them. So it doesn't even consider any of the classes or the definitions coming from those files. It just doesn't even process them. The next level up is typed false, which is the default. So if you don't put any strictness level on top of your files, Sorbet assumes it's typed false. And at typed false, all your classes and modules and all the constants that you use in your code, they need to resolve. So Sorbet needs to understand that if you're using some class name called user or shop or admin or whatever, then it needs to understand where that type is coming from. So that's the minimum thing that you want. But the types aren't checked. The signatures aren't checked. You don't need to put any signatures anyway. So typed false is like the introduction level, the entry level to Sorbet. After that, and the sweet spot is to be at typed true. Typed true is when things start getting really interesting. At this level, type errors are now reported. This means that Sorbet now starts checking to see if the methods that you're calling are actually defined on the classes that you're calling them on. If the methods actually have the correct number of arguments passed to them. So we're still not doing type checking, but we're checking to see if methods exist. We're checking to see if the arguments match. And then if the method actually has a signature, Sorbet also checks to see if we're passing variables of the wrong type, or when we get the type back, that the parameter is of the type that the method returns. And these are all reported as errors. You don't necessarily need to put a signature on top of your methods at type true. But at type strict, this is a little bit more strict. It requires all the methods in that file to have a signature, right? That's what makes it strict. So it's like type true, but it says, I'm being strict in this file. I want every method that anyone adds, even later, to also have a signature, right? That's to make sure that no one can like add something that doesn't have a type into a file that's marked at type strict. And there's another level called type strong that even the Sorbet team doesn't advise you to use. And it's very, very strong. It's only applicable to like very 2 or 3 line simple Ruby scripts. Other than that, it gets like broken really fast. And I don't necessarily want to go into too much details of like what it does, but at that level, all errors are reported. So this is how you can opt into type checking on a per file basis, right? So we covered the file level granularity. Now let's look at method level granularity. Now so I'm still giving the same user example. We still have the same class method name from hash. But we also defined a new method called age. So each user has an age. In this case, age returns 45. But this age method is not type checked because we didn't put a signature on it. Remember, we at type true, we're not required to put a signature on top of any method. We have a signature on top of the method name from hash, but we don't need a signature on top of the age method because it's simple. We know what it does. It just returns a number. So we can opt into one method having a signature and opt out of another method having a signature. And if we run this code, by the way, I also, in this case, fixed the problem with the code. So this code should just type check properly. We can also do argument level granularity. So it's simplifying the previous example. When we do class user and then def age and 45, if we create a new instance of the user, and if we call age on it, it obviously returns 45. And if we do user.country, we know user doesn't have a method called country. So Sorbet would give us error method country doesn't exist on user, right? Which makes sense. That's the safety that we want. If we call a method on user that doesn't exist on user, we want Sorbet to give. We can try to get out of these restrictions from Sorbet if we know that the country method definitely exists on user. Suppose this is an active record model. The country method might be coming from the database, and maybe it doesn't exist as a declared method on user. Then maybe in that case, we know that the country method actually exists. So in that case, we can create a new user and tell Sorbet that this new user instance should be untyped. So tlet is a Sorbet way of saying assert, like make the type of this thing into this other type. You're saying I want this user to be untyped, and then you get a user that is untyped. For untyped means you can do anything you want, right? Sorbet basically stops type checking from that point on. So if you call .country on untyped user, Sorbet says, fine, you told me you know what you're doing, this is untyped, so I'm not going to say raise any errors. And if you call .country, excuse me, that also returns a T untyped, because what else Sorbet can assume. So you can also call .capital. This won't give any errors either, because country is also untyped, so capital is also untyped. So in this case, city will also be untyped. So using this T untyped, you can opt into doing method level granularity. So if you remember, we set the T hash as having symbol keys, but also having string values. But in this example, I changed the values to be T untyped because this means, because the previous version meant the keys had to be symbols, but all the values needed to be strings. But maybe the hash that I'm passing has a name and an age as keys, which are both symbols, that's fine. But age is going to be a number and the name is going to be a string. So I want the values to be anything in the hash. So I can change it to be T untyped in the hash declaration. So that this then enforces the keys to be symbols, but it doesn't enforce anything about the values. It just treats them as anything you want. So now this still works, and you can still fetch the name and return a string, and you can still return this as a string. So Sorbet can actually work with this. And not putting a signature on age is actually the same thing as putting the signature sig returns T untyped, right? Not having a signature means I'm not interested in the types from this method, so Sorbet treats it as being untyped. So you can choose to mark some of your arguments as being T untyped, so you can opt out of type checking for those arguments, just like how I opted out of type checking for the values in the hash. There are some cases where you might need to have, opt out of Sorbet type checking at a given call site. And the biggest reason why you might want to do this is when there are methods defined at runtime. So Ruby is a very, very dynamic language, and we can define a lot of methods at runtime that are not visible statically. But if you remember, I already told you that Sorbet only works statically, right? So Sorbet doesn't load your Ruby code, it doesn't execute it, it doesn't try to understand what it does. It just tries to understand the types and if they're correct or not. So Sorbet, when it sees like this define method, has no idea what's going on, because this is something that happens at runtime, right? But at runtime, we know that A has an instance method called foo, which runs this. And A also has a singleton method, a class method called bar, which runs this, right? So this is all happening at runtime. For example, there are many things that are happening like this inside of Rails. If you work with Rails and if you work with active record, when you create a new active record model, you just get an empty file, right? Like, where are all the attributes? You defined many attributes for your model, but they don't exist inside the file. So when you look at it, it looks like there are no methods on this user model. But actually at runtime, there are many methods on the user model, and those are defined dynamically by looking at the database. So Rails does something like this inside. It uses a lot of defined method. It uses a lot of defined singleton method. So this is just an example of me like showing what might happen. So in this case, if I create a new instance of this A class, and if I call foo on it, Sorbet will say method foo doesn't exist on A, because Sorbet won't be able to see this method definition because that method definition is dynamic. And it could even be conditional, right? Like, if this happens, define this method, else define this other method. There's no way Sorbet can actually make sure that those if conditions will be true or not at runtime. The if condition could be dependent on a file existing. The if condition could be dependent on some URL return value or something, right? Like, there's no way Sorbet can statically know if the method will be defined or not, because it's being defined at runtime. So the best Sorbet can do is to just not process these defined methods and things, and it doesn't. It says there's no method foo, it doesn't exist on A. But what we can do, we can say, I know what I'm doing, right? Like, I'm just going to take my seatbelt off for a minute here because I know what I'm doing. I know A has the method foo. So I can say, okay, now make A unsafe so that you can allow me to call .foo on it. This T unsafe basically turns A into T untyped so that you can call anything on it. So you can opt out of type checking for just this call, right? You're not opting out of type checking for the whole file or for anything else, but just for this call, you're saying to Sorbet, I know what I'm doing. Trust me, I'm just going to be unsafe here. There are some cases where there might not be a receiver. For example, the same class A, suppose there's a class B that is subclassing from A. It can actually call the singleton method bar inside of B. But again, Sorbet will say method bar doesn't exist on the class of B, but we know it's actually coming from A, the same problem, just a different context. But in this case, there is nothing for us to say this is unsafe now, right? Because previously we had the A instance, small a, where we could say T unsafe A. But in this case, there is nothing like that. But there's always self. This bar is actually self.bar. So we can always use T unsafe on self and call .bar, and this will be okay, right? Sorbet will say, okay, again, you told me for this call that self should be T untyped, so you can call anything on it. So what about the $1 billion mistake? So I'm not sure if everyone's familiar with this, but the person who originally introduced the concept of nil or null in other languages, later on regretted it, saying it was my $1 billion mistake. How many times did you have like a null reference error in your code, or nil class in your runtime errors or something? This like concept of being nil or being null actually cost the whole industry billions of dollars. And the inventor of nullness actually called it his $1 billion mistake. But Sorbet actually helps us there as well. So with Sorbet, types are not nillable by default, and you have to explicitly say T nillable to make them nillable. So I'm going to make the example a little bit more complex now. So again, the same user model, let's make the age a little bit more complex so that it accepts a birth date, which might be nillable or not, right? So we might be passing a birth date optionally to this age method. And if the birth date is passed, then we want to calculate the age based on that birth date, and then calculate age can do like really hard date mathematics to calculate the exact age. But in this case, calculate age is always expecting a date. It's not expecting anything nil. It's just going to assume that the birth date that's passed to calculate age is not nil at all. It's just going to assume it's going to be a date and work on it. But for age, we said the birth date can be nillable, right? So it can be nil or a date. But in this case, we will get an error for the age method because we also say the age method returns an integer, right? But in this case, it doesn't always return an integer. It returns an integer in the case that we have supplied the birth date by calling to calculate age and returning the value it returns. But in the case we don't supply a birth date, nothing happens. The method will actually return nil, right? So that's a nilable check that Sorbet is doing for us. It says you're trying to return, you said that you are going to return an integer, but in some cases you return a nil. But you have to return an integer in all cases from this method, which has an easy fix because Sorbet understands flow typing. So the fix is, right, we had a bug in our code for the cases where we didn't pass a birth date. So the fix is easy. We just add an else condition and return 45, just like how we used to have it previously when the birth date isn't passed, right? So in this case, if the birth date is passed, then Sorbet understands in this context that birth date is not nil because we already checked for it. If it was nil, we wouldn't be inside this if condition. So it can also assure that this calculate age will be called with a date object all the time. There are many, many more features in Sorbet, like the runtime type checker or Ruby interface files, flow sensitive typing, which I just pointed out a minute ago. There are generic types for representing more complex typing structures. There are union and intersection types and exhaustiveness checking. And you can go and look at the documentation of Sorbet. They have great documentation at sorbet.org/docs. And they have a wonderful playground at sorbet.run where you can run through some examples and try different signatures and try running some of these code examples that I gave here at the website without even downloading any software. But I also promised some magical things, right? So far I've been showing you seatbelts, and in some cases they've been uncomfortable, but we also said that we're going to get more out of this. And the things that you get are editor integration. So this is really magical. So Sorbet actually has inside the Sorbet executable an LSP mode. LSP is a language server provider, which is a protocol developed by Microsoft. The Visual Studio Code team developed this protocol. So now it's a protocol that allows any language to expose features about that language to any other editor. So it's like a unifying thing between multiple different editors and multiple different languages. So they only speak one language between them. So Sorbet actually implements this. So using Visual Studio Code or using Vim or using RubyMine or whatever, any editor that supports LSP, you can actually use the LSP mode on Sorbet, and it gives you like hovering, it gives you errors. So in this video, you can see that initially the charge ID was misspelled. So it had the squiggly things under that, and it says charge ID doesn't exist on this class. When you fix it, it gets fixed. And when you hover over the things, and it shows you like where they're defined or even what the value is. It also gives you the powers to go to definition. So right-clicking on the retrieve method actually takes you to the definition of retrieve method. So anyone who's worked with Ruby and try to get their editor set up to do these things can actually appreciate how hard this is for a language like Ruby, because the definitions are scattered and it's not always obvious where things are. And this is super useful for people who are just getting started with Ruby or with a new code base. It also has autocomplete and documentation. So when you're writing like stripe charge dot retrieve or something, you just type RET and then it just does autocompletion, and you can see that like it has documentation of that method does on the side. And it might even be able to autocomplete some of the arguments for you. So these are really magical. And you can also build more tools. We are in the process of building more tools at Shopify on top of Sorbet to allow us to analyze our code base. So I'm just quickly go over our experience of adopting Sorbet at Shopify. So we first started experimenting with Sorbet on our code base in November of 2018. I joined the company December of 2018. And then I joined this team, and we officially released support for it at the end of April 2019 on our main code base. We are running semi-custom tooling on top of Sorbet. So we use Sorbet for static type checking, Sorbet runtime for runtime type checking, but not in production. We have a tool that we built in-house, Tapioca. It's used for RBI generation for gems. I have a Ruby Kaigi video that talks about how Tapioca works. So if you're interested, you can go and watch that, or you can go and look at the repo. We have Rubocop rules for related to Sorbet to enforce certain rules across your code base. And we also have a new tool called Spoom to encapsulate some Sorbet operations. So Spoom is our tool to build better tools on top of this Sorbet static type checking. And we're releasing custom tooling back to the community as open source. So all of Tapioca, Rubocop, Sorbet, and Spoom are actually open source projects. Tapioca, just quickly, is the cost of entry for Sorbet is, like I said, all your constants to resolve, but Sorbet doesn't type check any of the constants coming from your gems or your gem dependencies. And SRB init does a decent job, but we wanted something better. So Tapioca loads your gem file, finds the gem source code, and tries to do runtime reflection to discover ancestors, mixins, method subconstants, and generate separate RBI files for each of the gems so that Sorbet can understand where the types are coming from and which methods they have. Just quickly, our results. So over about, so over 35,000 Ruby files in core. Core is our large Ruby on Rails monolith. We have about 80% of our files at typed true or higher. And we still have about 20% of our files at typed false, but we're trying to increase that number as well. And when you look at the percentage of all method calls across our code base, almost about half of them are calling methods that have a signature defined, and the remaining ones are basically opted out of type checking. So this is a pretty good result for us. And we also have some testimonials from different teams that worked with Sorbet extensively in their part of the code base. And we've done in-person interviews with them. So the things they liked is they get quicker feedback than waiting for tests to run. Using Sorbet allowed them to write less tests in the first place. And both static and runtime type checkers caught errors not caught by tests alone. It's easier to use in new code rather than adding signatures to the code you already have. And it improves code quality and makes you design better code because you're thinking with types in mind. It also becomes living documentation of the public contract of your code, so that when someone new joins the team, they can just look at the signatures and understand exactly what's being expected by this method and what's being returned. So it makes it easier to onboard people. What they disliked is the syntax is verbose and it reduces code visibility, but there are some like editor tooling to help with that. It's not very dry because you keep repeating yourself. You declare the arguments both on the method and on the signature. And sometimes types can get hard to write in more complex cases, and it's hard to add types to existing code. Finally, Rails and other metaprogramming is not fully functional yet. We're trying our best to add that functionality inside of Tapioca as well, but it's still not fully perfect. How can you adopt Sorbet in your code base? First of all, I will advise you to start using Sorbet in new code that you're writing in your code base, rather than going back and trying to add Sorbet in your old code, which becomes cumbersome because you didn't write that code thinking with types in mind. It becomes harder, and it becomes hard to understand exactly what's being returned or exactly what's being expected. So I would advise you to start using Sorbet in the parts of your code base that you're writing from scratch. And whenever you can, and when it's easy, you can add signatures to existing methods across, your older parts of your code base. And like I kept mentioning across this presentation, use gradual typing to your advantage, and only add Sorbet and only opt into typing in the parts of your code base that make sense, where you feel you need those extra safety guarantees. So fasten your seatbelts. It's worth the minor annoyance. And we can make the tooling better over time. You can contribute to Sorbet yourself as well. So thank you for listening to me. Again, my name is Ufuk Kayserilioglu. You can always reach me at Paracycle on GitHub or Twitter. I work at a small company called Shopify, and we're recently this year gone global, and we're a digital by default company now. So we're recruiting people from around the world. So if you go to shopify.com/careers, you can maybe see an opportunity there that you might be interested in as well. Thank you for listening to me today.
Ufuk, we appreciate your time. Thank you so much for joining us.
Thank you. It's been a pleasure.
Same here. Thank you so much. And to everyone who's on this call, we also appreciate you. Keep the conversation going, and looking forward to the next series that we have planned for you. Thank you so much. Stay safe and be blessed. See you.
Bye-bye.